So today's topic for Hive is partitions. This is a very important topic in Hive, and today I'm going to cover what is partitions, what is it used for, and how many types of partitions we have, like static and dynamic partitions, and how to load data into static and dynamic partitions. So for that, we need to have a example table. So let's go to MySQL root. So the table I'm going to use is SQL table. Here you see select. This is a table I'm going to use. We have 1000 records. So this table I'm going to show you in Excel sheet also. This is in here. So that table is I put it on the Excel sheet also, so that we will get more clear understanding of how partitions happens and how to create different types of partitions. So just to go through the data, this table have multiple columns. So I'll be concentrating on the columns called department and country. So this table has let's say if you wanted looking for departments, it has that list of people from different countries working in different departments. And there are more other lots of other columns also, but let's just concentrate on this columns, department and name and last name. And so let's say if I want to filter out, if I want to see only the columns for accounting, so I can see only the records for accounting, and I can see so many rows in here. And in accounting also, if you want to see list of persons in particular for particular country, like example Bahamas, it will show me this one. So we are going to pull this data set. Let's assume this data set is in RDBMS data, and we are going to scoop this data from RDBMS and put it into Hadoop, and after putting into Hadoop, we're going to create partitions on top of it. So this I'm just went through the example, but I'll give you'll understand more when I go through the data by creating partitions. So where is this? Okay. So partitions. So partitions in Hive. Why we should implement partitions in Hive? So by default, all the data files for the table are located in single directory. When I say single directory, I mean this one. So when you load data into Hive, by default, it's in a single directory. Only one directory will have all this data. Like for 1000 records, it will be sitting in one directory. So in those type of non-partition tables, so Hive, when you try to run a query, Hive would have to read all the records in the table data directory and subsequently have to apply filters on it. So this applying filter on all the records on the table will slow down, and it's an expensive process. And especially with the large tables, over here you just see 1000 records, but in real-time scenario we will have millions of records, like 100 million, 200 millions of records. And if you try to query such a large volumes of data, it's very slow and expensive if you don't have partitions. So partitioning itself is a technique for physically dividing the data during loading based on the values from one or more columns. What I mean to say that is dividing the data based on the columns means it will divide data based on the column that you choose. So let's say if you're choosing a column called accounting, so it will create a folder for accounting, and under folder it will put all these records into that folder, and subsequently it will create folders for every column in here. For every column it will start creating folders, and each and every folder will have its corresponding data in it. So like that, we can create multiple partitions. Like under accounting, if you go, this is only accounting data, right? Under that, we can also create multiple partitions. Like under accounting, we can create a partition called country. Inside it, we will have multiple partitions. So this partition is used to speed up our queries and which will improve the performance. So most most of the time these partitions will be like on the date field or the country field, depending on the use case. So let's say if we have a use case for a company where it's ordering lots of inventory orders, so that orders depend. So when it orders, they might have a condition all the time to check number of orders ordered per month or per day. So for those kind of use case, there will be a partition based on the date, and inside that date, they will have all the records of the orders for that particular date. So that's one thing. And when to use partition? So partition is, let me write it down like this. So when to use partition? So partitioning we use, let me see. Give me 1 second, guys. So when partition, to use partition. So we have to decide when is if we want to create partition on a certain table. So that depends on our in the data sets. If our data set is large, which has millions of records, so especially these data sets will normally require full table scans. So for that kind of data, we need to create partitions. But it's not all the case. So I'll tell you when also. But so for first, let's assume that for all the large data sets that's performing queries, those large data sets requires full table spans. But there are some instances in these large data sets where you normally put where conditions. So let's say this table has 100 million records, and you have a always put a where condition in this table for like date. You're looking for orders that got booked on the particular day, or you're looking for orders for only particular country. So for that kind of scenario, you know that you're always going to use this where condition. So for that kind of scenarios, you can we have to create partitions, and inside the partitions we put only the corresponding data. So common columns that are frequently queried like are the year and country. So those are the ones which we create partitions on. And these columns that we going to create partitions should be of low cardinality. That's very important. When I say low cardinality, it means that it should not have lots of distinct records. So when I say low cardinality, this is low cardinality because when you see distinct records in here, out of all 1,000 records in here, there might be only 20 records for these columns. This is called low cardinality. But let's assume if you have a row number, which is a unique number, which we don't have in here. But let's assume this on the left hand side. This you see on the left hand side, you see all these row numbers. We cannot choose this as a partition because this is having a high cardinality. And if you choose this as a partition, we get folder created for every row. So that means we will have 1,000 partitions, which will not improve performance. In fact, it will degrade performance. So always when you're choosing partitions, pick a column that has low cardinality. And and one more example I can give also. So let's say, so good for partition is if you always have some a query conditions like this from table where country is. So for this kind of queries, if you use very often, so then try to create partition on countries. So I'll give you an example also where you are not supposed to create partition. So where you're not supposed to create partition is, so for queries like this, select star from table. So if your requirement is always trying to pull the data completely from the table, then we should never create a partition, because no matter if you create partition, then it will go into the that particular partition and try to pull the data. But if your query requirement is to pull all the data from the table, then partition is not getting used. So instead we are wasting the resources by creating multiple partitions. And there are other scenarios also. I'll tell you where we should not be using partition. So we should not be using partition if we have a small data set, and if we are not going, if our queries doesn't use where condition, we should not be using partition. And also I told you, right, if the columns have high cardinality, then no partitions on that column. And then also where else we can use partitions? So, and also we have to carefully select a column while creating partition. The reason is, if you're trying to create a partition, let's say on the date, year and month is still okay because you might not have so much of data. But if you're trying to create partition on every minute, then you will end up creating lots of partitions. So what happens in real time is, when you create so many partitions, right, it will, all these partitions will go into Hive. All this partition will go into Hive Metastore. So Hive Metastore will keep track of all the partitions. So if you create multiple partitions, then it will take time because this Metastore is going to pull up in the memory, and it has to read that Metastore, and it will find which partition is going to which table. So if you have so many, let's say if you're creating it by minutes, so then you will create 100,000 partitions per a table. So all other 100,000 partitions will be sitting in this Metastore. So since we will have so many partitions, and if that partition doesn't have large volumes of data, then it's a time consuming for Hive to go back to the this memory, look for the partitions, and it's a wasteful of resources also. So we have to make sure is we should not do a over partition of data. So pick a right column for the partitioning it. So other than that, so we saw the advantages of partitioning is it's actually used for distributing load horizontally on the table. And since the load is divided into the slices and parts, I can show you in the picture also. So let's assume this is HDFS data. In this data, let's assume we have a partitions, as we discussed, as we saw in the Excel sheet. We have a partition on department. Let's say department is equal to, and we have customer relations. So this is one partition. And we will create another partition. We'll create 3 partitions. We'll pick another department. This is another. So let's assume we have we created 3 partitions in a table. So in these partitions, we will have some data sitting in there. Let's say in customer relations, we have in customer relations we have 68 records. So let's assume this has 68 records, and this has 100 records, and this has 200 records. So now let's say you are querying data. Let's say our query is saying that select count of star from table where department is customer relations. So if we query this, first it will go to the Hive meta store. In this Hive meta store, in Hive meta store it knows that in HDFS for this table we have 3 folder structure, and each folder it knows that which folder we have created partitions on. So once you run this query, it will directly come in here and query the data. And since it's not going for any other locations, all it has to do is go in here for the department relations, and only in this folder it has to check all the data and it will bring back the data. So this will be faster if it is the partitions. Let's assume we don't have any partitions and we just have one table, whole table, and all 365 records are sitting in here. In this, if you query data for this type of scenario, it has to go through each and every record and find which one is customer relationship, and out of that then it has to find out how much is count of that customer relationship. So here it's scanning 365 records, but over here it's only scanning 68 records. So that means this has a very good performance. So this is what a partition is. And we also have some limitations. So we also have some limitations in this partitions also. So for example, like having too many partitions in these tables can create large number of files and directories in the HDFS itself. So that will become a overhead for the name node. It will be a overhead for the metadata of the file system. So we have to be careful while creating so many partitions. And so while using partitions, it may optimize some queries. Like here you have optimized a query saying that where department is customer relations. Let's say if you have a query where you say department is customer relation, but if you want to group by some other column, so in that scenario it has to go back to not department, but let's say if you have just select star from table, and then if you're grouping by some other column which is not partition, then it still has to go through each and every table to get that group by conditions. So for that kind of scenario also it's a little limitation, but don't worry about all that limitations for now. Let's go ahead and start jump into practicals and start doing some let's start creating some partition table. So okay, so I've shown you that our data set is this one. Okay, and I have pulled this data set, I scooped this data set into this location. I've already scooped this data set to a Hadoop location. If you're curious, I can show you the query also, but since it takes some time, I'm not gonna run it. But our query is scoop import, connect, username root, password, and I'm just querying the data. I'm querying all the columns, and split by, I'm using ID, and the target directory, and put it into this location. So let me go and check that location. User Shiva scoop stage. So I see all the data in here. It created 4 mappers, and each mapper has 250 records. So we have all 1000 records sitting in here. So now let's go ahead and create a table on top of this scoop data. So how we are going to do it? So let's go ahead and create a non-partitioned table. Okay, let's do that first. For that, let's go ahead and connect to the Hive. So to create Hive table on this data, so I'm going to create an external table. So as we discussed in the last class, we use create external table. Table name is non-partition. I'll just use np underscore table. Then I'm going to use all the columns in here. I'm not going to type all that. Used all the columns, and I'm going to specify row format delimited. Fields terminated by. All the scoop fields that we scooped into Hadoop are terminated by comma. So I'm doing fields terminated by comma. Stored as text file. I'm storing it as text file. And on which location are we creating this Hive table? We are creating external table on this location so that this Hive table can read all this data. So we have to specify that location. Location as user Shiva scoop stage. So it's done. Now let's go and query this table. So it's running mappers and reducers now. So after this, we will see concept of static partition and dynamic partition, because all we saw is a partition, but inside partition there are 2 types of partitions. One is creating tables by using static partitions, and then creating tables using dynamic partition. So we will see those concepts. Those concepts are also really important. So it's taking a little time. Okay, it looks like it's done. So we got 1000 records in here on the Hive table. So let's go ahead and create a partition. Create external table. I'll say static partition. I'll explain you more what static partition, but let's say static partition is we have to pass some value while creating a partition table. But let's assume let's just go ahead and create this partition, and I'll explain you later. So static part, I'm creating a starting partition table. In here, I'm specifying all the columns that are required except partition column. So in here, now we want to make a partition on department column, right? So what I will do is except department, I will select all the columns except departments and create table on it. So here that's what I did is first ID, last name, phone, email, address, city, postal region, country, status, and company. That's what you see. So except department, I've created all the columns. So this is the list of columns. And then comes the partition file. Here we have to mention the department. By department string, and then rest is again row format delimited, stored as text file, location. Okay, I got a typo in here. That's fine. Let me write it down. So what I'll do is I'll just copy this. Okay, what I did is I created external table. I'm selecting all columns except this one. The column which we want to partition, it will not be in the list of columns in here. So this column is virtual because our columns, I'll show you in when you see the actual folder structure, you would know. But these are the columns which we have to specify except the partition column. This partition by is virtual. Virtual means it will not be inside the file that we create. So let's assume if we created a file with list of all these columns, that this column will not be inside that file. What happens is a folder will get created by the name as department. Inside that folder, we will have a file with all this list of values. So that's what it is. So it's partition by. You have to specify outside the columns, and you have to use a parameter called partition by, department string, row format delimited, fields terminated by, and location. Let's specify user Shiva Hive sp underscore table. So stored as token. What happened in here? Input / expecting string literally a location. Oh, damn it. Location Shiva Okay, now table is created. let's go and see what actually this table says. Format. So I'm doing describe formatted to see the schema of the table. So when you see the schema of table, it's showing you as a column name as this, but it's not showing you the partition column. Instead, there's something else in here. Underneath that, it says partition information. It's partition on department. So partition column will never be inside the columns. It will be as a separate as a folder structure. So we should not be specifying the partition columns inside the column names. If you try to specify the same column name in partition and also in here, it will throw an error saying that the column name repeated in partition also. So now we created a partition table. So how should we insert data into this partition table? Let's see that. So let's do this. Let's write insert. So we have actual table. So we have this table called, where is that table? Static partition, non-partition table. Thought I created non-partition table. NP table. Where did I create it? Oh, I created in default. That's fine. I'll go and create the same table in training. So if I'm just getting show create table statement. I'll take this. I'll copy that. I'll drop it from this. Then I'll go to this database, use training, and here I'll create this. Okay, now if I see, now I see this is non-partition table which has all the 1000 records, which is this, right? And this is a partition table, but it doesn't have any data yet. I just created the table. So what should we do if we want to insert the data into this table, but it should be partitioned? So I'll tell you how. So first, let's go and see how the data looks in this table. So I'm going into non-partition data. User Shiva Hive scoop stage. Okay, in non-partition data, the data looks like something like this. So let's go ahead and see the folder structure for partition data. User Shiva and location is static partition table. So now you don't see any data in here. So I'll go and create some partition data. To create some partition data, I'll do is insert override into table sp underscore table, and I'll specify what partition I'm using. And in this partition, I'm using department is equal to, let's pick one department, which is this. Let's pick department called accounting. So accounting, we have 62 records. So paste accounting, and then what I will say is I'm going to select everything again. ID, first name, last name, phone, email, date, office, address, city, postal, region. Number, color, status, and then company. Remember here I'm not selecting department, because in actual partition table, static partition table, this is static partition table, I don't have department in here, so I should not be selecting this. I have ID, first name, last name, phone, email, amount, row ID, status, and company, but no department. So that's why I'm not selecting that at all. So status, company, and then I use from non-partition table, which we have 1000 records, and then here I would say department is equal to I did Control C. Sorry, I need to log back into Hive. So here what I did is I did insert overwrite. So I did insert overwrite into this partition table. I'm specifying partition, and I have to specify which partition. This is important that it depends on you which partition you're selecting. So in department accounting, you have to make sure you're only inserting that partition. So it's a completely on our query that we have to make sure that we are only inserting the account data into that partition. So let's go ahead and line table. Department is insert. Okay, insert override table. Department is equal to insert overwrite. We should not be saying as into, because we are overwriting. If we insert into table, then we have to specify into. It's a overwriting, it should be insert overwrite table, and then rest is same. Okay, insert overwrite table, table name, partition, and then select this, all this. Where is the minimize? I'm trying to find my other window. It's look like it's gone. Terminal. Ooh. Sorry guys, 1 second. So now I create
So Shiva,
accounting and advertising, and I'm running the query only for advertising. Yes.
hello.
Hey Karthik. Yes.
Yeah. This is like it is creating again it is created in the physical memory, right? There is some memory allocated to these partitions again, right?
Physical location. Every partition will have will it creates a location, a new folder. Underneath that folder, it will save the data for that particular
Yeah.
partition.
So I mean, there is no any kind of any virtual table kind of creation thing in this. Can we do that, or it's only like again we have to create something in the memory, like views or something like that in our SQL kind of thing?
Create views also in this, but this is a different concept where creating by partitions. But yes, as you mentioned, yes, views can be created on this top of the tables, which can query the data underneath these tables. But this is a physical location. But if
Oh, okay.
you want, we can create views on top of this data, and then it will read this table data.
Oh, okay. Okay. Hello. Hello. Can you hear me? I'm unable to hear anything. Like,
Hey
are you
Karthik.
talking?
Yes, Karthik. I'm sorry. Yeah, I was talking. I was on.
Yeah.
So what I was telling is, so right now we saw all the static partition. So now we had to go and manually create these two partitions. One is accounting and one is advertising. What if we want to create all these partitions? So instead of writing multiple insert statements for each and every partition, there is a concept called dynamic partition in Hive. So instead of we going writing all these partitions manually, Hive will able to figure out all these partition locations, and it will corresponding partition names. It will insert and create a new partitions for that. So I will show you how to create a dynamic partitions. Let's go ahead and create a new table. and then I'll show dynamic partition on that new table. So I will create the same exact table, but I'll call it as dynamic partition, and the location also I'll change it. So let's say create table, show create table static partition, right? So I'm going to take the same exact create table statement and then I'll say dynamic partition and table, and then I'll use same exact query, except location I'll specify it as user Shiva Hive. I'll specify it as dynamic partition table. Okay, I need to specify them in both at the same time. So and then I will specify this location, copy, paste, and then location I'll specify as user I had this twice in here. So partition by string and until this location. Shiva Okay, now I created another table which is called dynamic partition. So how are we going to insert data into dynamic partition table? So let's do this. So we are going to use the same exact query that we used earlier for static partition, but there will be a small change in that. Instead of specifying the static data, we're going to call it dynamically. So the same thing, you do insert override table. I'm doing dynamic partition table. Dynamic partition table. I'm specifying partition. Since this is dynamic and we don't have to specify anything, so we will not be specifying anything. We should say dynamic partition table department, select ID, first name, last name, phone, email, region, amount, call status, and very important thing in here is we have to specify the last since we are specifying this dynamic partition in here, so it has to get the data from somewhere. So that's the data that it's going to create for this dynamic partition should be specified at the end. So the difference between a static partition and dynamic partition is, in static partition you won't specify any column at the end. You will specify that column in here in partition department is equal to admin. But in dynamic partition we have to specify that column name at the end, which is here. And then all we do is we have to remove everything. So this is a query. So insert override table partition department, You're selecting everything and you're also specifying the column at the end from no partition table. I'm guessing we'll get an error, but I'll tell you why and why also. Let's go and run this. Okay, this is expected. The reason is Hive by default sets the mode to, it's called strict mode. So strict mode is nothing but this will so this will help us for any query by not creating multiple partitions which will internally affect the performance. So the reason this is by default at the strict mode is the dynamic partition is disabled and the reason for this is to prevent accidental partition creations. When I say accidental partitions creations is if by default it's in non-strict mode, what happens is if you can run query and let's say by mistake if instead of department if you have a minute, so it will create 100. Let's say if you have a column for every minute, then it will create so many partitions for every, so it will keep on creating, like let's say if we created 1 million partitions, that will impact the performance and it might have an adverse effect on the metadata when you try to read the number of partitions from that meta store. So that for that reason Hive forces us to put it in a strict mode. So by default it's a strict mode, and what we have to do to make it non-strict mode is we can set commands in Hive to change it from strict mode to non-strict mode. So I'm using strict Hive dynamic partition, make it non-strict. Once you do that, it will let us run this query. It ran it. So the concept in here is by default dynamic partition will be in strict mode. When it says strict mode, it means that it will force us not to create partition dynamically. It will let us create partition dynamically, but for that we have to specify it has this partition should have at least one static partition, and then we can create a dynamic partitions. So that means if it is in a strict mode, we have to use two partitions in which one is static and others are dynamic. So now you see it created partitions, so many partitions. Let's go to the data. This is data. So I'm querying the dynamic partition underscore table. So now it created all this for us. So we didn't have to manually go and write it. All we did is insert statement, select department, and at the final in that select statement we are specifying that column name, and it went and created us. But for us to create a dynamic partition, we have to set dynamic partition mode non-strict. By default it is strict. We have to set partition mode non-strict. So what if we want to let's put it back to strict mode, and I will show you something else. Okay, what if you want to create multiple partitions? So let's say if I have a partition called, I'll pause here to make sure you guys are understanding it. I'll pause here to ask any questions. So okay, so what if you have to create multiple partitions? Let's say multiple partitions is you already have a partition on advertising. So this advertising partition has so many records. So what if you want to create another partition inside advertising for multiple countries? That means under advertising, if you want to create a partition for country, Mexico, it has one record. So what if you have a requirement to create multiple partitions inside the partition? So for that also we can do it. We can specify any number of partitions while create table statement. So let's go ahead and see by creating two partitions. So I will create partition one on department and another on country. So let's go ahead and state that. I'll clear this, log in back in, and then so until now, just to refresh, we saw what static partition in Hive. So in static partition in this mode, input data should contain the columns listed only in the table definition, and inside that partition you will statically specify the column name and the value, and that's how you do static partitions. But in dynamic partition, by dynamic partitions is disabled, it's in strict mode. The reason it's in strict mode is to prevent accidental partition creations. So to use the dynamic partition, what we saw is we set the parameter called Hive execute dynamic partition mode into non-strict mode. There are two more. Also, we have to set Hive execute dynamic partition is equal to true. I will show you all that. Okay, so let's go ahead and create a table which contains two columns. Let's say create table. Sorry, let's go ahead and create external table. Let's say this has static partition and also dynamic partition. And can you guys guess how many columns are we going to use here? What columns are we not supposed to use here? Let's say I'm creating a partition on two columns. One is department and another is country. So can you guys guess what we will have in this columns list? Am I going to create department and country in the column list?
No, I mean, you will only create country. That again, you'll be using it on what was that other one?
Partition by.
Partition.
So do I need to specify department and country in the list of columns?
Yes, I guess, Shiva.
In the list of columns when I create this?
No, in the columns we will not mention, but in the partition we will be including them.
Exactly, yes. So now since I have department and country, I removed country from here, department from list of columns, but I am going to mention that in partition by. In here, I'm going to specify those two columns. And same exact thing. We'll do row format input fields terminated by stored as text input, and then I will go ahead and create Shiva sp underscore tp. This is my folder. Okay. Let me do this. Show tables. I'll take exact same table, create table, show create table as a dynamic partition table. I'll take this same exact thing and then create dp and then I'll take everything except country. So I took this one except country, and then I'll take everything from here. And then I'll do by department string and also country string. And then again same thing, fields terminated, all this will be again same until here. Location, missing end of file, it fields in here. Oh, have this partition by missing end of file, it fields. Shiva Hive SP underscore TP, and then string okay. I created external table, I removed country from here, and then I put partition by string country string. So now if you see this guy formatted, it will show you two columns in the partition information. So now let me go ahead and create a query that can insert into these two partitions. So earlier we saw query for dynamic partition. So we can use the same query for that as dynamic partitions, but we will do very minimal changes in there. Before using this dynamic partitions, I'll show you. We will set a default. Since we are using dynamic partitions, we have to set this 4 parameters. One is, so whenever we use dynamic partitions, we have to set execute dynamic partitions is true, so that we are telling that we are using dynamic partition. And then we have to set command, we have to set this is configurations. It's actually changing the configurations from default to this one. So it's making true, it's making non-strict, and maximum dynamic partitions it's allowing is, we are saying at 1000. We should not be creating more than 1000. So if we try to create more than 1000, it will throw an error. So after setting this, let's go ahead and write that insert statement which we created earlier. So let's take the same statement, but we'll change a little bit in here. So when we are creating a dynamic partitions, let's mention that this one, what we are going to mention is here. We are mentioning that we are going to have department as advertising, but we want dynamic partitions on country. So here what we did is we did one static partition and one dynamic partition. And then what did I mention in here when we have dynamic partitions? So can you tell me what should be here?
Where department should be advertising?
Yes, that's perfect. Good, Kranti. Department is advertising. But I also mentioned something very important when using a dynamic partition. So when you specify dynamic partition, the last column should be the one which you are specifying in here. So since we are making country as dynamic partitions, that will be a last column. So you are removing that column from here and you are making it as last column. And since you're specifying static in here, the static column should not be in select statement. So there are two things. When you're specifying static, you have to put some condition in here. What is static? So we are specifying department is advertising. And also when you're specifying dynamic partition in here, it has to be the last column in here. So let's go ahead and run this query. So it contains non-partition columns. Department, what did we? Oh, I did not give the right name. The table name in here is actually sp_dp, right? See, if dp_table had only one partition, dp_table had only department as partition. So that's why it's saying that you're trying to query for the non-partition columns. Our table name is sp_dp. So now when we query this table, which is sp_dp, can you guys guess what will be under that sp_dp? Can you guys guess the folder structure?
It should be advertising, one folder with advertising.
Yes, perfect. And
the other one should be country.
Your part right. It should be advertising. That's correct. But not other one. But inside advertising, you will have country. Because if you see this sheet in here, what we are doing, we have 27 records in here. So technically, this country is inside this department, right?
Yes.
Not so. So that means we will see department, and inside that you will see country.
Yeah, it's a combination. Yeah, I get it.
So,
thanks.
So we will see it as like this. And then if you enter, then you have to see all the countries inside it. See, you see all the countries inside department. This is how you do partitioning it. So this is called multi-level partition. So until now, we saw static partition, we saw dynamic partition, we saw static and dynamic partitions, and how to set what needs to be set to the dynamic partitions. And we saw insert, override, create tables, what partitions it had, and one more thing. So how, let's say if you want to see all the partitions for that table, so what command do you have to type to see the partitions? Because you don't, you know that location is this one, user Shiva Hive, which is this. You know this location is here, but if you have 100,000 records, you don't want to go and query this complete location, right? All you know is the table name. So by knowing the table name, how do you know that if it, how many partitions have been created? So the command for that is, all you do is, it's very simple. You do show partitions and specify the table name. Sorry, you need to log in into Hive first. So here I'm doing show partitions. Let me clear this out for you so that it will be easy. So logging back into Hive. In here, then we will go into use training, and to see partitions, you say show partitions and you say sp underscore table. So in show partitions, it showed us we have two partitions. So let's do the same thing for dynamic partition table. So for dynamic partitions table, it showed us all the list of partitions. Let's see static partition and dynamic partition table. See, the difference is, for dynamic only with one partition it will show like this, but if you do show partition with static and dynamic, it will show department advertising, underneath that you have a country, department advertising, underneath that you have this country. So this is how you see show partitions. So tomorrow we will see how to pull partitions from scoop, and in HDFS if you want to put it into since Hive table already exists, all these partition which you are doing, you can pull only this this advertising while pulling it from RDBMS, and you can put it into that location. So we'll see that example tomorrow, and we'll also see how to alter this table to add new partitions or delete existing partitions. So that's all for today. So if you have any questions, you guys can ask me now. Okay guys, so